Okay, this video we will continue to go through the Set 3 end of year 2021 paper for pure physics. So I think this video we will start with the heat transfer question 8. So in this question you are given two bodies, the water cylinder and a piece of ice at the bottom. So in part A, they are asking you to state the direction of the heat and they are asking you to explain. It is a 2-mark question with 3 answer lines, so you will definitely need to give a bit more detail. So to get the first mark, you just need to state what is the direction. So in this case, when it is in terms of heat transfer and we talk about direction, we are not asking you for upward, downward, left or right, but rather it is from which body to which body, right? So in this case, the heat will move from the warmer object, which is the water, to the cooler object, which is the ice. So to get the first 1 mark, you need to let me know is from the water to the ice. To get the second mark, you need to explain. So to explain that, it is pretty simple. Heat will move when there is a temperature difference, and it will move from high temperature to low temperature. So as long as in your answer you can show me that you are aware that the water is warmer or hotter and the ice is cooler, we will give you the second mark. For part B, you are asked to state what is the main heat transfer in part A, meaning that the main heat transfer from water to ice, and since both of them are in contact, then the main heat transfer method would be conduction. Now for part C, we are not asking you to describe convection, but rather we are asking you why is it that the water on top stays warm. So there are 4 answer lines and it is a 2-mark question, so we would require a bit more content. Now another thing about this question is a lot of students misinterpret the question and move on to describe how convection happen in water. For example, you can see from this candidate, the question is asking you why water at the top remains warm. But if you look at this candidate, the answer says at the bottom, the water in contact with the base of the cylinder, blah blah blah. What it says, in the base of the cylinder which is in contact to the ice, and then full stop. So you can see that when you look at the first sentence, you can see that the student is not planning her answer. She is just writing out whatever that has appeared in her mind. So when you answer heat transfer question, it really requires you to have a very clear state of mind, and you need to be able to describe the process in steps. So you can do that by practicing before the exam. But if you run out of time to practice and you couldn't do that, then maybe during the exam it's best to actually sketch out a diagram and ask and quickly plan on the side what is the first thing you want to talk about. So if I were the student, I would first say something like, okay, I agree with the student that first there will be heat loss from the water to the ice. So therefore the water at the bottom over here, they will contract, and therefore the density would increase and it will sink, right? But so far in step 1 and 2 of my explanation, I have not addressed the subject of the question, which is the water near the top. So it means that in my third step, I would definitely need to say something about the water at the top. So I will say something like, oh okay, so the water at the top is warmer, and so what will happen is that they will stay afloat, right? So it means what? It means that I do not have a convection current set up. And then maybe the fourth, I say that, oh, although there's no convection current, can conduction happen? Yes, conduction can happen, but it will happen very slowly in water because water is liquid. So conduction will happen very slowly as conduction requires the collision of neighboring particle. So immediately after I plan this very quick diagram, I know that, oh, I have 4 parts to talk about. Then what I will do is that with these 4 parts, I will then now write out my full answer. So like I said, I will start with step 1 first. So I say something like, oh, the water at the bottom, well, I locate where does my where is the start of my entire process, right? It starts with water at the bottom. We'll lose heat to the ice, just like what she did, right? Its density rises. So for me, I will always put a trigger and then I write down the immediate effect, right? So I'm done with step 1. In fact, I have covered step 2. But step 2, I didn't mention the sink. So meaning that in my next sentence, I will say something like, oh, as a result, the cool water at the bottom and the warm water on top will remain afloat, right? The cool water will remain at the bottom because it sinks, ma. Then the warmer water will just remain at the top. And I may add in a line and says that, oh, therefore no convection current formed. But so far, by answering up to this point, I actually have not really thought about why is it that it will remain wrong, because heat transfer can happen in 3 methods: conduction, convection, and radiation, right? So far in step number 1, 2, and 3, I have explained why convection is not the way to go, right? So I still have conduction to talk about. So maybe I will add in one more line and say that, oh, water is a poor conductor and hence the top layer of water cannot, oh, wrong. Because in heat transfer, it is a force of nature. You cannot say cannot happen, right? It will just simply lose heat to the bottom layer of water slowly. Okay, so poor conductor simply means that the process will happen slowly. It doesn't mean that it won't happen. So it is very important for you to be very mindful if you are using absolute terms. So this is how you tackle the question, okay, in 4 steps. And you can see that in each of the steps, when I describe it, I pay very close attention to the subject of my sentence. Water at the top, water at the bottom, right? I will describe it because I know that those are the key for me for my reader to understand me. Okay, in the next question, we are checking whether you can do calculation in terms of MC delta theta and latent heat of vaporization or fusion. So in this case, like I said, whenever I'm doing graph, I am very mindful about what is the unit. And if I see a unit that is not SI unit, I will definitely put a star there to remind myself, hey, you better take care, right? Then when I read the table, I will also be very careful. When I see that there are things like kilojoules, I will also highlight to myself that, hey, be careful, this one is actually 336,000, huh? Okay, so these are some of the good habits that you really need to start to cultivate. Okay, if not before, when you reach step 4, you will find that, hey, wow, I keep getting wrong. I'm always giving incomplete answer, and then in the end I get 0, right? Okay, for part A, as you can see here, the candidate didn't pay close attention to the unit. So in fact, when he read 5, it is correct, but it is in minutes. Yeah, so that's why I say that you need to develop this awareness. It takes time, but although I say that it takes time, there are techniques and habits that you can adopt to speed up this process. It's whether or not you are following it or not. Okay, now next thing, for part B, you are asked to calculate the loss of thermal energy, and this student directly substitute the numbers into it. Now I don't really like this, especially when you know that you are weak in calculation. I rather you start off Q equals to MC delta T. How long does it take to write this formula? It doesn't take long, but when you are doing a checking of paper, you can then check each unit. Did you substitute the right thing? Is the mass in kg or is the mass in gram? Is the specific heat capacity in kilojoules or what? So for this student, I know that she is not very strong in mathematics. She is slightly stronger in her languages, and yet she is not doing what I have taught her. So this one I'm a bit upset lah, huh? Okay, but what I like about her is that she's follow what I teach her. She wrote down the full value and then round it to 2SF. So for this, she did a great job. Okay, for part C, again, I do not like what I see because I can see that her mind is in a mess. And why her mind is in a mess is because she doesn't follow what I teach her. Right? I told her after you write down the heat loss and heat gain, then you branch out how many terms are there. So what do I mean by how many terms are there? For example, after you write down heat loss, and then heat gain, I want you to break it down. So heat loss by water is just cooling down of water. There's no state change. It is just 50 degrees C to 5. But when it comes to ice and it is gaining heat, there are two terms. First, you will have to melt the ice from solid to liquid. Then after the ice turn into liquid, it will be still at 0 degrees C, which means that this melted ice would need to be warmed up from 0 to 5. So this is what I mean by term number 1 and term number 2. Okay, so after you expand that, and of course remember to use the full form. Okay, you are expected to show me your working. I will not be showing you in this video, but I will let you know this is the correct answer. Okay, so in your correction, I expect you to show me the full working with proper presentation. Okay, now in part D, they are asking you explain in molecular terms how evaporation help to cool down the hot tea. And this question has been asked in your homework. And I'm still very unhappy. Why do you say molecule gain energy? Molecule doesn't gain energy for this particular instance because your tea is already hot. It is losing energy, right? Thermal energy is lost from high temperature hot tea to surrounding. So whenever you see evaporation, evaporation does not gain energy. Okay, it doesn't. I have said many times in the class, but yet you are still thinking that, oh, my molecule escaped, so therefore it must gain energy. No, it is a spontaneous effect. The molecule simply will escape. That's all. It doesn't gain energy. There's no heat source to gain energy from. In fact, you are the hot object. That liquid is the hot object. It is losing energy as a whole. So therefore, do not give me this nonsense anymore. Okay? So in evaporation, don't ever mention gain energy. It doesn't. It's spontaneously the molecule leave the surface due to random collision. Okay? You don't even need to mention due to random collision. Okay? So that is her first mistake. Second mistake, can you see here? Molecule can leave the surface and okay, this I can't read. I don't even want to give marks. But I know that she's trying to say evaporate. So what is she trying to say? Energetic molecule evaporate. Can molecule evaporate? No. Molecule doesn't evaporate. Liquid does. So be mindful of your subject. And again, this answer shows that the candidate is just writing everything out from her mind. She's already nervous, she's thinking, and then she cannot make clear her mind. So you need to plan. So how I plan? I always plan with a picture because I remember it as a picture. You don't want to memorize it as a picture, can. 1, 2, 3, 4, 5 then. Right? 1, I need to talk about this very happy molecule. 2, they are living. So 3, it left with the lazy ones in the liquid. So what are some keywords? Energetic molecule. It doesn't gain energy. They just are energetic, that's all. Okay? Be mindful, not all energetic molecule can live. This energetic molecule has to be near the liquid surface. Right? Then after that, talk about the process. Then after that, talk about the effect of the process. Right? When the more energetic one left, it means what? It means that in the liquid, the average IKE drops. Now please take note, IKE of liquid, not IKE of molecule. There's nothing inside the molecule already. Okay, if you want to say average KE of liquid molecule, fine. If you want to use IKE, then it's of liquid, no more molecule. Okay, then conclude. Hence, the temperature of the liquid drops. Okay, so that's how you describe evaporation. Okay, for the whole 2021, you need to learn this because in set 4 we're going to ask you. It's a very common question.